This conference will now be recorded.
So, good afternoon, Dr. Jaspal Singh ji, and all the dear participants. So today, as we are going into second day of our this FDP Environmental Geotechnology, we have Dr. Jaspal Singh with us. So first of all, I would like to welcome sir to this platform to give us lecture, expert lecture on the topic utilization of waste for sustainable construction. So before sir can start his presentation, I would just like to give you a brief introduction of Dr. Jaspal Singh ji. So although he is associated with a number of responsibilities, a number of associations, and he has done a lot of work during his this career of teaching. So I would just emphasize on a brief biodata of Dr. Jaspal Singh ji. So sir has done his BTech in civil engineering from one of the premier institutes of our country, that is NIT, National Institute of Technology, Surathkal, that is from the state of Karnataka. And he is holding two master degrees. One is in the discipline of structural engineering, and other masters he is having in the field of soil mechanics and foundation engineering. And he is also recipient of merit certificate at master's level, and he had the proud privilege to be selected by Jawaharlal Nehru Memorial in recognition of his academic excellence at postgraduate level. So, and sir has achieved his doctoral degree in civil engineering with 88.4% marks. He has served a number of institutes in this region of the country. Out of these, a few are Thapar Institute of Engineering and Technology, Patiala. Then he served at Gyani Jail Singh College of Engineering and Technology, Bathinda. And afterwards, he joined the most prestigious institutes of India, one of the most prestigious institutes of India, that is Punjab Agricultural University, Ludhiana. And he has been presently serving there for the last 23 years. Uh, Dr. Jaspal Singh initiated his career at PAU Ludhiana as an assistant professor in the Department of Civil Engineering. And then he got selected as associate professor in November 2001, and then joined as professor in the year 2009. And along with all other responsibilities, he was also holding the charge of chief engineer, Punjab Agriculture University, Ludhiana, for 7 years. And during his this tenure, a number of construction activities at different Krishi Vigyan Kendras in all the districts of Punjab were taken out. And presently also he is holding the charge of chief engineer. This is another one university which I am going to name. He is presently the chief engineer of Guru Angad Dev Veterinary and Animal Sciences Husbandry. This is also located at Ludhiana. So apart from his academic responsibilities, Dr. Jaspal Singh has served the country in various capacities. So here I cannot name those responsibilities as the biodata will go very long. So briefly, I will like to comment here. Jaspal Singh has also published about 150 research paper in different esteemed journals, proceedings of conference and seminars. And his contributions have been recognized by various institutes of the India, like Punjab Technical University, Bathinda, IK Gujral, PTU, Jalandhar, then Punjabi University, Patiala, Punjab University, Chandigarh, Thapar University, Patiala, DAV University, Jalandhar, Jai Narayan Vyas University, Jodhpur, Chaudhry Charan Singh Agriculture University, Hisar, Rajasthan Agriculture University. He is on the panel of all these universities for different responsibilities. So he has been also selected as fellow of 4 professional societies, and he is a life member of 2 international societies and 10 national societies. And he is also a co-editor of a journal named as Journal of Current Sciences and reviewer for technical papers for Indian Geotechnical Society and Journal of Institute of Engineers. Dr. Jaspal Singh has visited a number of countries for various international assignments as a part of different Indian delegates, and he is also associated with a large number of consultancy projects which has been undertaken by the Civil Engineering Department of Punjab Agricultural University, Ludhiana. So to conclude in one line, I must say that Dr. Jaspal Singh is a mentor of myself as well as my whole department. So here I would like to finish. So now I welcome Dr. Jaspal Singh to this platform and request sir to please continue with his lecture. Thank you, sir.
Thank you very much, Dr. Borsingji, for your kind words, which I think I don't deserve all. So today is the second day of your FTP on environmental geotechnology. Today, as you know, is a very important day for us, for engineering fraternity, because today we are celebrating this day as Engineers Day. So heartiest congratulations to the organizers, Dr. Bor Singh, Dipinder Deep Singh, and others, Gurpreet, Pavandeep, for organizing this course. And also I heartiest congratulations to all the participants. I see that you have the participants from 15 states. Telangana, Gujarat, Maharashtra, West Bengal, Jharkhand, Tamil Nadu, Uttar Pradesh, Odisha, Andhra Pradesh, Haryana, Madhya Pradesh, Karnataka, Kerala, etc. So that's wonderful. So today we'll be just discussing about what various wastes are there, and we'll be concentrating on only one or two wastes, the research which have been carried out by my students, that I'll discuss so that it will give you a platform for further research purposes. So as far as the topic is concerned, it is utilization of waste for sustainable development, sustainable construction. So we'll be discussing this. Amongst this, we'll be discussing what is sustainable development and what are the various wastes, how we can use those wastes, and what research we can carry out as far as those wastes are concerned. So what we will start with the sustainable development. What is sustainable development first of all? And some people who know, they can just write in the chat box so that we can accordingly coordinate.
So anyone desirous of writing what is sustainable development can write it in chat box.
Person has written development along with nature. So it is basically the ability to meet the needs of the people in the present without compromising the ability of the future generations to meet their own. So it is right that development without interfering with the nature, we call it as sustainable development. So as far as sustainable development is concerned, we have many definitions for sustainable development. So there are basically three pillars of sustainability: social, environmental, and economic, or we can call it as three P's. That is people, people is social, then planet, planet deals with environment, then we have profit, that is economy. So that means sustainability, there are three pillars, and if one pillar is weak, then the whole system is unsuitable. So sustainable development, under sustainable development, we have construction, sustainable construction, which is defined as the practice of creating structures and using processes that are environmentally responsible and resource efficient throughout a building's life cycle, from setting to design, construction, operation, maintenance, renovation, and deconstruction. So there are various ways. There are various ways which we can deal with, and sustainable construction will include methods which include renewable and recyclable sources, reducing energy consumption and waste, creating a healthy, environmentally friendly environment, protecting the natural environment. So why do you think that wastes are necessary to be incorporated in construction in addition to the regular materials? You can write in the chat box so that once we discuss the wastes and then we can move ahead.
Sir, your mic is off, sir.
No problem. I'm waiting. I'm waiting for the people to write.
Okay. Fine, sir. Fine.
So as far as wastes are concerned, they are classified into two categories: agro wastes, industrial wastes. Agro waste, we have rice husk ash, corn cob ash. Some of these are sugarcane bagasse ash, banana leaves ash. And industrial waste, we have fly ash, ground granulated blast furnace slag, and silica fume. So again, waste can be categorized, and our always intention should be to utilize these wastes. A lot of studies have been carried out regarding these wastes, and we should select the waste in such a manner that we are able to substitute that. So as far as cement is concerned, we can use fly ash, we can use ground granulated blast furnace slag, we can use condensed silica fume, cement kiln dust, etc. So what we are going to do is we are substituting the materials for cement, and we are reducing the greenhouse gas emissions. We are controlling the alkali silica reactivity, and we are improving the durability. So again, materials we can substitute for fine aggregates. Those can be crushed sand, it can be crushed dust or quarry dust, granulated blast furnace slag. Thing is, we have to look for the parameter while replacing the materials. Let us say when we are replacing fine aggregates, we have to look for the material which is basically chemically inert and having particle size falling in BA's zoning criteria, preferably second 2, would be ideal replacement to river sand in concrete mixes. Similarly, we have coarse aggregates. Coarse aggregates, again, we can replace with different materials. So a lot of study has been carried out regarding wastes. So today what I'll do is I am going to concentrate on the latest study using only two wastes. First, I'll discuss regarding the fly ash, and then I will discuss regarding rice husk ash. The normal study regarding the waste have been published before also, but regarding geopolymers, it's a new concept. And from only last 2 years, the study have started in India as far as geopolymer is concerned. So we are basically geopolymerization, we do it, and we are using the alkaline activators in order to have the geopolymerization. Geopolymer cement concrete is made from utilization of waste materials. It can be fly ash, it can be rice husk ash, it can be GGBS. So now we come to what are the alkaline activators. They play an important role in the hydration of the binders. The most popular activators are alkali hydroxides and silicates. So these are the types of alkaline activators: sodium hydroxide, sodium carbonate, etc. So in alkali activation, we are mainly dealing with the molarity, number of moles of solute per liter of solution. It is used to express the concentration of solution. The molarity of solution is the way to figure out how much of a specific element or compound has been dissolved or used in a certain amount of solution. So this is what I'll be discussing today. So that is regarding alkali activated fly ash. So there are two objectives. We study the compressive strength of fly ash based geopolymer containing nanometer, and then to study the microstructure and pozzolanic properties of fly ash based geopolymer containing nanometer. So the materials used are fly ash, alkaline activator solution, nanometer, fine aggregates, and water. These are the methods: geopolymer mortar mix design, compressive strength, then XRD thing. So geopolymer mortar is a two-phase material similar to conventional Portland cement mortar, consisting of geopolymer binders and aggregates as a source and filler materials respectively. There are no codal provisions or standard design methods. So what we have done is we have adopted the same procedure as that of cement mortar, but we have activated the fly ash with the help of alkaline activator, and we have conducted the study. So the major components which affect the strength of geopolymer mortar mix are geopolymer binder to sand ratio, water to sand solid ratio, alkaline activator solution to fly ash ratio, sodium silicate to sodium hydroxide ratio, molar concentration or molarity of sodium hydroxide. All the above discussed ratios were fixed in the study, but the molarity was varied in order to see the effect of alkaline activator solution. So fly ash samples were prepared regarding geopolymer, and as far as preparation of the samples is concerned, first of all, the standard consistency of the fly ash was determined, and by taking approximately 400 gram of fly ash, and then with the help of wicket mold we have done that. Then initial and final setting time was determined. Only thing is, preparation of fly ash based geopolymer mortar was difficult because we had to make a lot of trials. First of all, fly ash to sand ratio was selected. Then alkaline activator solution to fly ash ratio was selected. That was based on the consistency, and it was checked for strength requirement, workability requirement. Then sodium silicate to sodium hydroxide ratio was selected. Selecting a definite molar concentration of sodium hydroxide solution and mixing was done, and solution was kept for 1 day before prior to casting, because there is a lot of heat which is generated and we have to keep it cool so that we are able to determine it. Then trial mixes were proportioned by varying activated and fly ash. Trial mixes were tested for verifying the compressive strength. So that means compressive strength was determined using the procedure similar to the determination of cement compressive strength, but in geopolymer mortar, alkaline activator solution was used instead of water. Cubes of standard size were used, and after an hour, cubes were placed in an oven at 70 degrees centigrade for 24 hours temperature curing. After that, cubes were taken out, and after demolding, specimens were kept at a room temperature for ambient curing till testing. So specimens were tested after 3, 7, 14, and 28 days. The compressive strength of the mortar cubes was found using UTM. So the next part which we have used is regarding the X-ray diffraction. It is XRD. It is a non-destructive test method. It is used to analyze structure of crystalline materials, and by studying it, we are able to identify the crystalline phases which are present in a material, and thereby we are able to know the chemical composition information. So it's a non-destructive analytical technique used for analyzing the crystal structure, mineral composition, and unit cell dimensions. X-ray diffractometers mainly consist of three components. cathode ray tube, X-ray detector, and sample holder. These X-rays produced in cathode ray tube are detected, processed through X-ray detector, and records in the form of intensity were noted. Conversion of diffraction peaks to D spacings, they allow identification of the mineral because each mineral has a set of unique D spacings. So this technique is basically primarily based on Bragg's law, that is n lambda is equal to 2d sine theta, where lambda is the wavelength of X-ray, theta is the refraction angle of incident ray, and d is the lattice spacing between the planes in a crystalline sample. The X-ray diffraction analysis were made with a diffractometer with the radiation having wavelength lambda is equal to 1.54 angstrom. The X-ray tube was operated. These are the standard conditions for operating the X-ray diffraction apparatus. These measurements were carried out in a 2 theta range. This we can vary from 5 degree to 89 degree with a step width of 0.008 degree, and the results as far as the properties are concerned, these are the physical properties of fly ash. It was F type, the particles retained were 31%, and as far as the chemical properties are concerned, the values of SiO2 plus Al2O3 plus Fe2O3, they are 94.36%. As per the codal recommendations, the value should be more than 70. Silicon oxide, dioxide 52.66. Again, the minimum value is 35. Calcium oxide is 1.64. Magnesium oxide is 0.84. The maximum value which is specified is 5. Sodium oxide is 0.02. LOI is 2.35. These are the physical properties of nanometallocolin. Nanometallocolin color was white. Bulk density, it was given by the source from where we purchased, and specific surface area was 12 to 18. Similarly, the chemical properties, SiO2, Fe2O3, Al2O3 41 to 44, CaO 0.016, K2O 1 to 2, Na2O 0.13. So physical and chemical properties of sodium hydroxide, physical and chemical properties of sodium silicate. These are the two activators which we have used, and then we did the fine aggregate sieve analysis. Then we have given certain names to the mixes, and to determine the value of compressive strength of fly ash based geopolymer mortar, 18 mixes were prepared by using different molar concentrations. Molar concentrations which were chosen, they were 12 m, 14 m, and 16 m. So cement and water present in the cement mortar was replaced with fly ash and alkaline activator solution respectively. The alkaline activator solution to fly ash ratio was kept as 0.4, sodium silicate to sodium hydroxide as 2.5, and water to solid ratio as 0.3 respectively. So in all we have casted 216 specimens of geopolymer mortar, varying molarity of the hydroxide and percentage of NMK with fly ash. So the nanometallocolin was varied from 0 to 10% with different molarity 12, 14, and 16. Fly ash, nanometallocolin was replaced with fly ash, that means 100. First of all, nanometallocolin was 0, fly ash was 100%. Then 2, fly ash was 98, 4, 96, 6, 94, 8, 92, 10, and 90. So S1 to S2, X6, they correspond to 12 molarity. S7 to S12, they are corresponding to 14 molarity. S13 to S18, they are corresponding to 16 molarity. So this was the designation of the geopolymer mortar mix. So then we have seen the mixes, ratio of alkaline activator solution to fly ash. It was kept as 0.4. This was also on the basis of the trials. Ratio of water to solids 0.3, molarity 12, and then 14, nanometric, then fly ash. Then after that, the alkaline activator solution was 0.4 into this fly ash. Then SH is sodium hydroxide and SS is sodium silicate. Their ratio was also kept as 2.5 depending upon the consistency, depending upon the trials, and depending upon the various research papers. So overall, this was the thing. We have calculated the different quantities, and we have, with the help of alkaline activator, we have casted the samples, and then we have tested the compressive strength. So regarding the compressive strength, this table gives the value of the compressive strength for different molar concentrations of sodium hydroxide. It is 12 molarity, 14, and 16 at various replacement levels of nanometric at the end of different curing periods: 3 days, 7 days, 14 days, and 28 days. See, at 0% replacement of nanometric, 28 days compressive strength of 14 molarity and 16 molarity was found to be 1.13 and 1.22 times 12 molarity samples. So this gives the compressive strength of geopolymer mortar for 0% replacement. This gives for 2%. For 2% replacement of nanometric, 28 days compressive strength of 14 molarity and 16 molarity was found to be 1.09 and 1.16 times the values which were given by 12 molarity. Similarly, for 4% replacement of nanometric, 28 days compressive strength of 14 molarity was 1.09 times, and for 16 molarity it was 1.16 times. Again, for 6% corresponding to 14 molarity, it was 1.15 times, and corresponding to 16 molarity, it was 1.3 times. For 8%, then for 10%. So it can be concluded that compressive strength of fly ash based geopolymer mortar is directly depending upon the molar concentration of alkaline activator solution. As molar concentration increases, it enhances the geopolymerization reaction by escalating the dissolution of alumina and silica present in the source material, which we call it as fly ash. The increase in compressive strength of fly ash based geopolymer mortar with different percentage levels of nanometric is due to contribution of silica and alumina oxide of nanometric NMK in the geopolymerization process. There is a significant increase at 4% NMK. If you look at, there is an increase at 4% NMK. It is due to homogeneous dispersion of NMK, leading to formation of nucleation material for geoformation. Compact structure was formed. However, if the composition of NMK is very high, it results in the formation of agglomerate that hinders the intact between reactive components of geopolymerization reaction. So this is for 16 molarity. For 16 molarity also 4% nanometric NMK was found to be optimum. Again, what we have done is, conducting the tests, we have found the regression analysis. From the regression analysis, we have computed a graph and we have formed an equation from which we can find out the value of compressive strength for different molar concentrations of sodium hydroxide and for different proportions of nanometer. So this is the measured compressive strength. Then we have predicted compressive strength. Then we have the residual values. Then depending upon those residual values, we can find the integral absolute error. And when we say integral absolute error, if it is less than 10%, it is always better. It is considered to be significant. So this error measures the absolute deviation of experimentally measured values from the values obtained using regression analysis. So in the range of 0 to 10, as I already told you, is regarded as acceptable value. So our value was 5.73%, so it is within the acceptable range. So again, X-ray diffraction test was performed, as I already told you. The X-ray test results were in the form of diffracted peaks of different geopolymerization reaction products. These diffracted peaks were marked on the basis of International Center of Diffracted Data (ICDD) database. Intensity of diffracted peaks was plotted against the diffraction angle. So this shows the X-ray pattern. X-rays are diffracted differently by each mineral based on the atoms present and their arrangement in crystal lattice of the mineral. So X-ray, if you look at the fly ash X-ray pattern, in its normal state, it's mainly composed of amorphous and crystalline substances such as quartz and mullite. Test results of crystalline substances, and this shows there are numerous peaks of mullite and quartz in crystalline phase. The highest intensity of quartz and mullite peaks were found at 6000 CPS and 1804 CPS and were indexed at 26.6% and 40.72%. So actually this was regarding the S1, and X-ray XRD test results indicate that in all the samples, phase of quartz was mixed with mullite. They were present. Quartz is SiO2 and mullite is Al6 Si2O13. And this is the XRD pattern of S7. This is the XRD pattern of S13, XRD pattern of S15. So what we can say is that compressive strength of fly ash based geopolymer mortar directly depends upon the molar concentration of alkaline activator solution. As the molar concentration of alkaline activator solution increases from 12 m to 16 m, it results in increase of compressive strength for all curing ages. This is due to higher molar concentration of NaOH, which contributes to enhancement in the geopolymerization reaction by escalating the dissolution of alumina and silica present in fly ash. The second conclusion which we can derive from activated fly ash is, I have intentionally taken this activated fly ash because a lot of research has been carried out as far as the normal fly ash is concerned. On activated materials, there is scanty, research is scanty. It's very less. It's the latest thing which is nowadays research is carried out regarding activated. We activate the waste and accordingly we carry out the research. Activating the waste results in more compressive strength as compared to the effect of it in the normal fashion. So second is, irrespective of the molar concentration of alkaline activator, there is a significant increase in compressive strength corresponding to 4% replacement of NMK. We found that beyond 4%, the increase is marginal. The increase in compressive strength with different percentages is due to contribution of silica and aluminum oxide in the geopolymerization reaction. So XRD test results showed that increase in molar concentration of NaOH from 12 m to 16 m increases the intensities of filler components, which contributed to the increase in compressive strength. From XRD test results, it was also observed that with the addition of NMK, geopolymerization reaction increased significantly and resulted in the enhancement of compressive strength. Same trend can be observed from compressive strength results using the machine. So XRD test results are in conformity with compressive strength results. So this is the compressive strength relation, and from this we could publish two papers in one of the important journals, Construction and Building Materials, because the research, this nanometallic and this geopolymerization mortar or geopolymerization process is something which is latest. And the other paper was in Ceramic International. Again, it was synthesis of fly ash-based geopolymer. That means we are activating the fly ash with the help of alkali activators in order to find out its effect on strength, and we have seen that the strength is compressive strength. There is increasing strength of compressive strength was found with increasing molar concentration of sodium hydroxide and curing period. Again, we have to do so many trials for this, and we could complete the research and we could publish two papers in important journals. So next I'll talk to again with the activated rice husk ash. Again, activation. Rice husk ash, simple, many people are using, and many papers have already been published. And alkali activating with rice husk ash is something new. So rice husk, as we know, is the hard protective cover of rice grains obtained from milling. So how many million tons of rice husk is produced annually? Can someone write in the chat box? Approximately how many million tons of rice husk is produced annually? Because it's a great threat, causing damage to the land and the surrounding area. So rice husk ash contains very high amount of silica content. The silica contained in rice husk ash can react with cementitious binders to perform pozzolanic activity. So during milling, what happens is 22% weight of the rice paddy is converted into rice husk, and then this rice husk is exposed to fire. About 25% of rice husk is obtained as a rice husk ash. So when we are alkali activating the rice husk with alkaline solution, it can be used as a geopolymer binder in mortar and concrete. So this is again, we have using the nano material, which are quite prevalent nowadays, and we are able to improve the strength and permeability using the nanomaterials. So nanometallic is basically produced by grinding the metacolin in high-speed ball grinding mill. It's an ultra-fine pozzolana produced by heating the kaolin at a temperature between 700 to 900 degrees centigrade, which consists of predominantly of silica and alumina. The use of nanometallic increases the life cycle expectancy and increases its durability. So nanometallic hikes the compressive strength of concrete and also makes it lightweight. So again, this study was dealing with the compressive strength of rice husk ash based geopolymer concrete, geopolymer containing nanometallic as a partial replacement of alkali activated rice husk ash. Rice husk ash is basically an agro waste fallout after burning of the rice husk. It's a byproduct obtained from processing of the rice grains. It has high amount of silica. Due to presence of high amount of silica, it possesses pozzolanic reaction, which give cementitious properties. The rice husk also has various applications such as silica gel activated silica, carbon and silicon chips, etc. The properties of the rice husk cache, such as physical and chemical, vary from one sample to the other. And our study was to deal with compressive strength and to study the microscopic and pozzolanic properties of rice husk cache based geopolymer containing nanometallic. So again, the materials used were rice husk cache, sodium hydroxide, NMK, fine aggregates, and water. The method was same: geopolymer mortar mix design, then compressive strength of geopolymer mortar. Then we conducted the X-ray diffraction test XRD in order to evaluate these results, in order to see what are the chemical compositions when we activate the rice husk with the help of activation. So the suitable ingredients of geopolymer and the relative proportions were selected with the objective of high compressive strength. Following factors influence the mechanical properties, durability properties, and microscopic properties: alkaline activator to binder ratio, alkaline activator to sand ratio, water to solid ratio, type of alkaline activator, concentration of alkaline activator, then temperature used for curing. So compressive strength of geopolymer mortar was determined as per the similar procedure as we have already discussed. And compressive strength was determined using the cubes. Geopolymer mortar was compared with 1 part of alkali activated rice husk cache and 3 parts sand. Firstly, cube molds were cleaned, and all this is all simple, which we normally do. And the specimens were kept for thermal curing. After 1 day, the specimens were demolded and they were tested. So these are the properties of rice husk cache. Particle shape is irregular, appearance, chemical composition, and other things. These are the properties of nanometallic. The mineral composition: moisture content was less than 1%. It is white. Specific surface area is 12 to 18. Bulk density is 300 to 340. The chemical properties are: SiO2 is silicon oxide is 51 to 54%. Fe2O3 is 0.35. Al2O3 is 41 to 44. Titanium oxide is nil. Calcium oxide 0.016. We have written it as nil because in some of the cases when NMK is supplied, the values are mentioned by the manufacturers. Loss on ignition is 1 to 2. And these are the properties of sodium hydroxide. So again, the properties were determined, and further simple sieve analysis were performed as far as fine aggregates are concerned. Fineness modulus was determined, and it was seen that the fine aggregates which we are using, we are conforming to zone 2. Actually, the main important thing is, as I told you, making this geopolymer mix. And geopolymer mix was designed depending upon the various ratios. And this design, again, 18 samples, 216 samples were prepared, because there are 3 days samples, 7 days samples, 14 days samples, and 28 days sample. Molar concentration of alkaline activator was selected. It was 12 molarity, 14 molarity, and 16 molarity. Nanometallic was varied from 0 to 10. Rice husk cache was replaced. It was 0, 100% first, and then it was 2 nanometallic, and rice husk was 98, and accordingly samples were casted. So this shows the calculations for alkaline activation and other things. As I told you, 216 samples were prepared, and on the basis of trials, we could fix the alkaline activator to binder ratio. We should fix the solid to water solid ratio, and the compressive strength of rice husk cache geopolymer mortar was determined for different days: 3 days, 7 days, 14 days, and 28 days. The compressive strength was determined. So this shows the compressive strength of the motor prepared with alkaline activator and 0% fly ash. See, the compressive strength of all the mixes was determined at 3, 7, 14, and 28 days for various replacement levels of nanometallic with rice as cache and prepared with different molarity of alkaline activator. The values at the end of curing periods are given, and it is seen that the compressive strength values at 0% geopolymer motor increase with the molar concentration of alkaline activator. Similar trend was observed in geopolymer mortar containing 2% and 4%. As far as this sample is concerned, the percentage increase for 2% represented of nanometallic. The percentage rise in compressive strength was 11.48% and 16.2%, 24% as compared to mix with 12 molarity. That means 14 molarity, it was more, 16 molarity was still higher. And when we replaced it with 4%, again there was an increase. The increase was 12.33% for 14M and 16.61% for 16M. Again, for 16 molarity, it was similar trend was observed. So there was increase in compressive strength with increase in molar concentration of the alkaline activator. Basically, this increase is attributed to the high dissolution of rice as cache, which is prompted by higher concentration of sodium hydroxide. When we are activating the waste, we are actually improving its properties. Similarly, it was with 10%, so 8, 10, and with 12 molarity, again, the effect of nanometallic on compressive strength was made with 12 molarity for different days: 3 days, 7 days, 14 days, and 28 days. The percentage of NMK was taken as 0 to 10%. That means 0%, 2%, 4%, 6%, 8% at the step of 2%. So this is as far as 14 molarity is concerned. So for 14 molarity, again, it was seen that for basically we concentrated on 28 days, and as far as XRD test is concerned, we performed it for 28 days. So then we perform the prediction equation, which is given by 18.742 plus 0.210 x1 plus 1.520 x2, where x1 is percentage of nanometallic, x2 is concentration of alkaline activator. The reliability of the given relation was checked on the basis of integral absolute error, which is determined from, as we have already discussed, from the observed values and experimental values, sigma under root OI minus EI squared divided by sigma OI. And if the value of IA is 0, that means the estimated values are equal to the measured values. It should be between 0 to 10. If it is between 0 to 10, it is regarded as an acceptable value for regression equation. So these are the values. The values comes out to be 5.0. If you look at 5.05, 376 percentage wise, 5.05. So that means it is less than 10%. That means our prediction equation is correct. So further, XRD test was performed, and XRD diffraction test, as we already wrote, it was performed on 4 samples: K1, K7, K13, and K16. The powdered samples were collected from the motor specimens after 28 days compressive strength test. Then it was tested in the laboratory. XRD results were present in the form of diffracted peaks of different geopolymer products. The intensity of these diffracted peaks were plotted against diffraction angle of 2 theta. X-ray power diffraction was used to determine the geopolymerization reaction of rice husk-based geopolymer mortar. Actually, the diffracted peaks of different reaction products, they can be determined with the help of X-ray power diffraction. So intensity of these peaks was plotted against diffraction angle of 2 theta degrees. So this shows the XRD pattern of rice husk ash. Rice husk ash contains high proportion of silica. XRD shows that the main constituent was SiO2 in the form of quartz and cristobalite. The major peaks of quartz were observed at angles, mainly if you look at here, it is 20.75 degree approximately and 26 degree, 26.8 we can say degrees. So XRD shows that wherever we have a hump located, when it gets disappeared, this means that there is a complete reaction of rice husk ash. So this is as far as K7 is concerned. This is as far as K13 is concerned. This is as far as K16 is concerned. So as far as conclusions regarding activated rice husk ash are concerned, the compressive strength of rice husk waste geopolymer mortar is affected by concentration of alkaline activator. The compressive strength of geopolymer mortar increases for all curing ages when concentration of alkaline activator is raised from 12 molarity to 16 molarity. There is significant increase in the compressive strength when the rice husk ash was replaced by nanometallic up to 6% in geopolymer mortar. Beyond that, there was reduction in compressive strength. The maximum compressive strength was obtained from mixed K16 prepared using 16M concentration. So again, XRD equation was found, integral absolute error was determined. So this is again, because it was the latest thing, alkaline activator thing is a new thing. It has come only during the last 2 years. We could publish a very good paper in a journal, Construction and Building Materials Journal. It is a highly reputed journal in compressive strength of rice husk based geopolymer mortar. So up till here, if you have any questions, you can write in the chat box so that we can proceed further.
Audience,
So
you
there
can.
we can answer to this question and then we can proceed further. So first question is regarding this is all right. XRD differentiated between quartz and molite. Actually, what happens is in the case of quartz, the peak will be more. It will be more peak, whereas in the case of molite, the peak will be less. And secondly, with the help of different color combinations, and we look for the different minerals which are present, and we can differentiate in the report that whether it is quartz or polite. And as far as sigma mac, sigma is, sigma means total. It is total. We find out the total value, that is sigma. In case still if you have any doubt, people can unmute themselves and ask. It is only to find out the value of integral absolute error where we are using the value sigma.
Sir, how it is calculated? Sigma C?
We calculate the total values and we divide it by the number of values. That's so simple.
Mean. As a mean.
As a mean, yeah. Actually, the thing is, in the numerator we have observed value minus estimated value, whereas if you look at the equation, whereas in the denominator we have only observed values. It is integral absolute error, and if it is less than 10%, it assumes that our values are okay. It should be less than 10%.
Sir, will you please see me the slide and calculate it?
Yes, 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 definitely. Just wait. This is the value. See, first of all, we
Okay.
have the measured values, then we have the predicted values,
Yes.
then we
sir.
find out E minus P, then
Yes,
E
sir.
minus P squared.
Okay.
Have you understood? Under root E minus P squared.
Yes, sir. Yes, sir. I got it.
So from this, we find out this integral absolute error. See, whenever you are doing any experiments, you should try to formulate an
Yes,
equation
sir.
so that you are able to see whether the equation which you have formulated is valid, is correct or not. So this is quite a useful thing, and I think you may not have seen it in any of the papers before. And we also got to know from foreign author papers that such things we can find out in order to validate our studies. Any more questions, please? Chat.
Anyone else who wants to ask some question regarding this up to now, what sir has covered? You can please ask.
Because this is, see nowadays what is doing, what we have, lot of study has been done regarding the waste. Regarding alkaline activator, studies are less. Only during the last 2 years we can see some papers regarding this. So if anyone is pursuing any PhD or something like that, nowadays the trend is of use of this nanotubes. One should try to see if one can use nanotubes along with some waste and find out the compressive strength. So this is even better than this alkaline activator.
Sir,
Hello. Should we move further?
place.
Should we move further? Singh ji?
Yes, sir.
Okay.
Dr. Sudesh Kumar ji, you put your question in chat box. You are not audible now. Sir will answer afterward at the end of the session. Dr. Sudesh Kumar, you are not audible. You put your question in chat box.
Write in the chat box. You can write in the chat box if you want.
So sir will answer it at the end of session. So sir, we should proceed further now.
Okay, there were only, see, it's, two studies which I wanted to highlight, and these were the research studies. But now I will do is I'll simply show you the simple use of waste. So we are talking of the waste, isn't it? So yesterday only I was looking at that we can also use plastic waste in road construction. Though it has been used in Punjab also, it has now been used in many roads, and there are many benefits for that. So there are a lot of problems due to plastic waste, and we have to, if we want to reduce this, we have to make use of this plastic as well as other waste materials in any fashion or in the fashion which is useful to us. So the solution is that we can have a plastic bitumen road. So even we can have multi-layered plastic roads. These are being constructed, and the cost is also less, and at the same time there is we can reduce the waste. So the raw materials for road construction, as we already know, they are aggregates, bitumen, and we can use base plastics. And road characteristics, See, surface roughness is more preferred. Tolerance for porosity is 2%, and moisture absorption is also 2%. So these are the bitumen characteristics. So the process involved in producing waste blast flakes are, first of all, we should segregate, then we should clean, then shredding process and collection process. So plastic is a good binder. See, if we increase the plastic coating, if percentage increase from 10 to 40%, there is significant increase in compressive strength, 250 to 320, and bending strength also increases from 325 megapascal through 390 megapascal. So there were two methods, dry process and wet process, and we can make use of these plastics in roads also. So if you look here, black is bitumen, blue is polymer, and gray is aggregate. First one is aggregate. Second is area of the plastics bonded with the aggregate, that is polymer coating we have. Then area of bitumen plastics blend, and we are able to have the blend. We can use the loosely bound bitumen with dispersed plastics, and we can have the plastic road because plastic improves the aggregate impact value. So this is just to highlight, this is not a practical thing. This I've just noted down from the internet, that there are certain advantages of plastic roads. That means we are able to use higher percentage of plastic waste. We are able to reduce the need of bitumen by about 10%. We can increase the strength and performance of the road. We can reduce the cost. Definitely, we can generate jobs for rag pickers. We can develop a technology which is eco-friendly. Of course, there are always disadvantages also. When we are concerned with advantages, we are also concerned with disadvantages. So it will start leaching, and the presence of chlorine will definitely release HCl gas. So plastic road will be a boon for India's hot and extremely humid climate, where durable and eco-friendly roads will derive the earth from plastic waste. Actually, our Chief Minister is also, last year, we had this Tandurust Punjab mission with the spirit of Swasth Hi Seva 2019. It was a campaign to save the future. So we should all move towards a plastic-free Punjab, or rather towards a plastic-free country, because I'm happy that people from 15 states are attending this short-term course or FTP, and they also will agree that if on this day, Engineers Day, we take a pledge that we have to use no plastic, at least in our houses, we can move towards sustainable construction, or we can move towards making and saving the environment. We can save our planet, and this is what the role of a great engineer should be. We should all move towards utilizing the waste in the best possible manner so that the cost is minimized, so that the depletion of materials, problem of depletion of materials is not there, so that there is less carbon emission, and with that we will be able to have the sustainable construction, we will be able to have the sustainable development, and as we have already discussed, sustainable development depends upon social, environmental, and economic effects. That means it rests on 3 P's. That means people, planet, and profit. When we say people, we are concerned with the social thing. When we say planet, we are concerned with the environment. And when we say profit, we are concerned with economic. That means there are basically 3 pillars of sustainability. And if we utilize the waste materials in the best possible manner, we will be moving towards the sustainable action. With that, I thank you one and all. In case you have any questions, you may please ask me.
Audience, please. Sir, Dr. Sudesh Kumar is
Hello,
asking. Yes, please proceed.
sir. You have shown that roads can be constructed with plastic waste. So what process is used there? Are the plastic at first burnt or some chemical process is used rather than this? Hello.
The plastic has to be crushed and then it has to be heated and then only we can mix it.
So sir, when we are heating it, some gases will be evolved from that, and that will be another problem.
That is always there, but it will be beneficial as far as the cost is concerned, as far as the use of plastics is concerned.
But sir, there will be serious health issues with that gases.
There are certain chemicals which we can add, which will improve this gas problem.
Okay.
There is one question: can we use strong base like NaOH and QH? We can use it, but it is recommended to use the alkaline activators, only the ones which I have mentioned, because when we use this strong base, lot of heat is generated, and we have to keep
Okay.
the solution for many days before casting the samples. If we use NaOH and QH, while activating the fly ash or ice ash gas or any other waste, we'll have to keep that solution. We'll have to keep that when we mix it with fly ash, lot of heat will be generated when we use strong base. So for that, it will have to be kept for 2 or 3 days before we cast the samples. Sudeshji, have I answered your question? Is there any disadvantage? There is no disadvantage in dry cast and concrete. There is always an advantage. Only thing is you have to use the optimum quantity. We have to look for the optimum quantity, how much we can use. We have to look into the research which is going on, the research which has taken place. Then accordingly we can decide. See, as far as rice gas is concerned, not more than 20% we can use. Because in addition to that, we have to use some other material also, and we have to look for the percentage. Then only we can say.
Audience, anyone else?
Hello, sir.
Hello,
Am I
Manjeet.
audible?
Yes, yes.
Yes, sir. I am
Please give
talking
your
about
introduction.
if
Give your
yeah,
introduction
I am
first.
Sabyasachi Mukherjee from West Bengal, lecturer in Shantiniketan Institute of Polytechnic,
Okay, good.
in the survey department. I would like to ask that if we use plastic in a road, is there any effect in design life? Because what we construct, the roads maximum that will last for 2 to 3 years. Is that affects the design life of the road,
See, as far
or
as
is
life is
that
concerned, it hardly matters. Only thing is, nowadays, if you look at even in Punjab, a multi-layered road has been constructed near Ropar. The first road was constructed using plastic near Ropar, and people have made it in CPWD also. People have started using plastic to make roads. The life is the life of a, no doubt, plastic road will be less than a cemented road, but it hardly matters because it is not that less.
Main point is utilization of our
okay?
waste.
Main problem is utilization of waste. बोर्ड सिंह जी मेरे ख्याल आई थिंक रोड्स अपने भी कंस्ट्रक्ट हुए हैं.
बिल्कुल सर हो रही हैं. A lot of work is going on.
We are using multi-layered plastics.
Yeah, a lot of
Hello,
work is
Jaspal,
going on
I
in this
thought
field.
it best that let me also introduce. Otherwise, it is not my area. It is Dr. Bor Singh's area.
Yes, sir.
Yeah,
So a lot of work is going on in
uh,
this field.
My main aim was to
Is
give
there
the impression of alkaline activators and to tell you what research you
yeah,
can do if you are pursuing PhD. See, if you use any waste material, using choice of alkaline activator is also required. We have to see which alkali activator we have to use. We cannot use very strong alkaline activators. And then we have to choose some other material also, because we have seen that using alkaline activator, the improvement in strength is enormous, enormous.
Yes, sir. So,
another question, sir? Is there any adverse effect of using plastic in a road?
Pardon?
I mean, where the temperature is more, where the temperature is less, we can use that or not use that like this.
I, I, I could not understand. Could you please repeat it?
Yes, sir. Is there any adverse effect? I am somewhere is atmosphere is 50 degrees centigrade in the summer, so there we could not use this plastic in road building. So is there any adverse effect like that?
Because in climate in Punjab just hot and humid, we can use it. In cold climate, there may be a problem.
Okay, okay. Thank you, sir. Thank you very much.
Welcome, welcome.
so participants, anyone else?
Hello, good afternoon, sir. Do you hear me?
Good afternoon.
Yes, sir. I am Midandas from West Bengal. Sir, my question is, sir, how geopolymer can be used for building constructions?
See, building construction, we are using cement, we are using mortar. It will take some time to use all these things, because these are something new things. But otherwise, if you look at, we are replacing the waste material, and we are alkaline activator, we are replacing the waste material, and we are, if we simply use fly ash, its strength is less. But if we do geopolymerization with the help of alkaline activator, definitely the increase in strength is more. But it will take some time to adopt to see. It takes time always to adopt to new technologies. Whereas in abroad, people have started using this geopolymerization technique in construction.
So, I think participants, that is sufficient. So, at the end,
Okay, sir. Okay, sir.
okay, fine. So, at the end, I would like to thank Dr. Jaspal Singh, sir, so for giving us a very good informative lecture on the utilization of these waste materials for sustainable construction. So as the sir has explained very beautifully the effect of nanometacolin on compressive strength of geopolymer mortar at different molar concentrations. So I hope all of us will be benefited by this technology. So that reactor technology which sir has explained to us. So and also the how can we utilize the waste like fly ash as well as other plastics which can be used in large number of construction activities. So we all must concentrate on all these fields. So I am really thankful to Dr. Jaspal Singh ji for such an informative lecture. Thank you, sir. Thanks a lot for joining us for this session. So
Welcome, Dr. Borsenji. I think there may be some internet problem in between. I think if that is the case, I'm sorry for that.
no,
Otherwise,
sir,
I think
it was
it
very
was
good. It was working very good. None of the participants has complained regarding this during the session. I think a little bit maybe there.
sometimes people don't give any complaints, but when they don't say anything, that means it's a complaint only. Please share my
Let's
email
say,
ID with one of the participants. He was Mr. Dr. Suresh Kumar was asking for that. We can share the email ID, my email ID. You can share with each one of them. So
sir,
no
I
problem.
will share.
Discuss. They want. They
I
can discuss. If they
I'll
want
share.
the copy of
I'll
the papers, that also I can just provide, or they can just look into the net and they'll be able to get it. This is
okay,
actually
sir.
something new, which I wanted to
Yes, sir.
tell you. Otherwise, waste, a lot of research has been done as far as waste are concerned. Alkaline activator concept is something new. And after this year, this will also go. Some other than this multi-wall nanotubes will come. So whosoever are doing PhD or intend to do PhD, they should they should look for the new materials such as multi-wall nanotubes and all those things. Thank you very much, Dr. Sir.
Thank you,
Thank
sir.
you for
Thank
the
you.
organizers
Thank
for
you,
giving
sir.
me a chance. Thank you,
Thank you, sir.
participants, for listening to me.
Thank
you,
Because,
sir.
listening to a lecture is more difficult rather than delivering a lecture.
and
Thank you.
that too in the
Thank you.
afternoon session.
That's in the afternoon session. Yeah.
Thank you, sir. Thanks for joining us. So,
Okay.
so thank you once again. So, dear participants, so our today's session is over. So we will meet tomorrow morning at 9:30 again. So good luck. Have a good day. So hoping to meet you tomorrow early morning. Thank you all.
Good day
Thank you.
and best of luck for the innovative days.
Thank you, sir. Thank you. Thank you.
Thank you, sir.
Thank you.